to catch all the books. Did you get my point?
Yes, sir.
If you just follow my slides, that will be enough. Okay. And for your reference, at the end of every slide, I have added the name of the books and name of the resources that I have used, or we have used actually to prepare this slide. Okay. So these are actually the course outline. So today actually we'll talk about the basics of renewable energy. For example, the statistics and what is renewable energy. So what are the advantage of renewable energy? So what are the disadvantage of renewable energy? What are the types? So we will actually talk about, or we'll focus actually on the actually very basic thing of the renewable energy. Okay. And afterwards, from the next class, we will move forward to the solar thermal system. And in the solar thermal system, you will learn different types of collectors, that is flat plate collector, cylindrical through collector, parabolic through collector. So you will learn actually those kind of collectors, including the evacuated tube collectors. Okay. And afterwards, I will move forward to the solar PV system. And in solar PV system, you will learn in detail regarding how a PV cell works, what are the classifications of PV cell, and why you required actually the maximum power point tracking. Okay, so maximum power point tracking, this topic is actually, I will start in final term, the first day at final term. Okay, and also you will learn how to design the solar modules and also the applications. Well, you already know the applications of solar PV system, so we will discuss regarding all of these factors. And also we will discuss about the losses of PV system. So what are the losses, and how much percentage of losses you will get in the PV system. So you will learn actually all of this. And then I will move forward to the wind turbine. And wind turbine, you will learn about the statistics of wind turbine nowadays, and also the wind turbine types, generator types, and how can you design the blades, how can you design the tower, and how can you control the wind turbine output. So these are the things we will learn in wind turbine. Then we will actually move forward to the biomass. And in biomass, you will get the idea of biodiesel, then biogas. So a lot of the factors actually we will discuss. And in geothermal energy also, you will get idea about geothermal resources. So you already maybe have some idea regarding geothermal, right? So you already learned it maybe in power station course, isn't it? Guys, so
Yes, sir.
Yes, sir.
okay, so you already know about geothermal. So we will actually discuss again in depth of geothermal energy. And finally, we'll move forward to the energy storage system, because energy storage is actually very vital nowadays. You already know that renewable energy sources are intermittent. What does it mean? For example, maybe now in Dhaka, if I talk about Dhaka, so now in Dhaka city, maybe there is no solar irradiance, right? Currently it's cloudy, isn't it? In Dhaka city, currently it's cloudy. So you will not get actually the generation from the PV system. So now you need actually the what? The backup system, right? And as a backup, maybe you need battery, maybe you need flywheel. So there are a lot of energy storage devices. Okay, so energy storage devices are actually vital part of renewable energy source nowadays. And we will actually learn about different types of energy storage system that we have actually currently. Is it clear to you? So we will explore actually a lot of the things, but very briefly, okay? Because you will get actually, renewable energy is a vast field, okay? So there are a lot of things, and there are a lot of things to learn, and there are a lot of things to actually adapt. But we will actually overview all the things, maybe in a small portion, or maybe you will get actually the basic ideas, so that you can actually get the interest to learn more the renewable energy near future. Okay, and also the motivation is actually, like, if you want, so you can actually will be benefited in your job life also. Okay, so this is actually the motivation of this course. And I got actually one interesting quote that is designed for tomorrow, because the day after tomorrow may be too late. So it's actually true for all the fields, right? So when you are thinking or when you are designing, so you have to design for tomorrow. So if you think about day after tomorrow, maybe it will be too late. So it's actually applicable for all the fields, right, students?
Yes, sir.
Or actually in our personal life as well, right? So if you want to do something, you have to this course also we will in terms of learnings and in terms of actually everything. So you'll be benefited actually. Okay. Any question or anything? Any question or anything? No, I think you're feeling bored, right? Are you scared?
No, sir.
Okay, are you scared?
No, sir. No, sir.
Sure. I think it seems like you are scared. So my voice maybe that's why maybe you are scared actually.
No, sir. It's all right.
Okay, that's good. So as I told already, so if you are comfortable with Bengali, so you can speak in Bengali. There is no problem with that. Okay, but I have to provide my lectures in English. But the informal discussions or the gossiping will definitely do in Bangla. Okay. Okay. So let's move on. Let's move on to the topic. So let me share or some basic terms with all of you, like the work, like the power, like the energy, kilowatt hour, joules, watts, calories, and then BTU. So maybe you have heard all of these parameters or all of these terms, right? Have you heard all these terms or all these parameters?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
What about BTU? So do you know about BTU?
So British thermal unit.
British thermal unit. Maybe you have learned in power station course. So BTU is actually, as you told, so it's a British thermal unit. So it's actually widely used by the mechanical engineer. Okay, if you want to actually talk about the thermal system, or if you actually define some thermal system, in that case, they are actually widely used the British thermal unit in the mechanical engineers. They use the British thermal units. Okay, but electrical engineers, we always actually talk about power, maybe in terms of energy, maybe in terms of work. But the mechanical engineers or other sorts of engineers, they actually talked about BTU. Even our air conditioning system, so the value is written in BTU, right? Maybe the cooling capacity is 24,000 BTU, maybe the cooling capacity is 18,000 BTU, and maybe the cooling capacity, what? Maybe 12,000 BTU. So 12,000 BTU may be considered as 1 ton, okay? And 18, if I'm not wrong, then 18,000 BTU is considered as 1.5 ton, and 24,000 BTU is considered as actually 2 ton. Okay, is it clear to you?
Yes,
so
sir.
ton is actually for the general peoples, but when you buy a AC, if you look at the catalogs or if you look at their manuals, it's written not in ton, it's written actually in BTU. Did you observe this scenario? So you will
Yes,
not
sir.
get any catalog or anything that is written in ton. So ton is actually for our mass peoples. But if you talk about the professionals, they actually always think about the BTU unit. Okay. Anyway, so you already know about all these things. Can anyone tell me what is work? Anyone have any idea regarding work? So what is work? Do you have
স্যার
any idea?
প্রতি সেকেন্ডে কাজ করার ক্ষমতাকে ওয়ার্ড বলে।
Right. Anyone else? Anyone else?
স্যার ফোর্স প্রয়োগ করে কোনো কিছুকে এক পয়েন্ট থেকে আরেক
স্মরণ করতে।
Okay, okay, that's good. Anyone else?
So force and displacement যেটা হয় স্যার।
Okay.
So W is equal to FA.
W equals to F into A. That means you are talking about mass and acceleration, right?
Yes, sir.
Okay, so all of you are actually correct. Okay, all of you are actually correct. The work has actually multiple definitions, but all of these definitions are actually talking about the same thing, as you mentioned already. Okay, so let me share my experience. Let me share my thoughts that is written in the slide. So work as an object, and if you apply some force, to move an object towards actually some distance against a resisting force, that is actually called the work. Maybe my definition is much more complex than you, right? I think yours one is much more simple, and actually it's much more understandable. Okay, so let me elaborate. Let me elaborate again. So work is done when you, let's say you have an object and you are moving that object to some distance by applying some force. That means you are doing some work, right? So if you have an object, some force to that object to maybe move some distance, or maybe to cover up some distance, that means you are doing some work, right?
Right.
Yeah. And also you already told me that work is actually the multiplication of distance. So, and obviously the applied force, the multiplication of applied force and distance, that will be actually the work. And also you can say the force is actually, what will be your force? The force will be actually multiplication of mass of that object and the acceleration that you are getting by applying that force. Okay, so this is actually the, if you talk about in terms of equations, this is actually the generalized equation for the work, and this is actually the generalized definition of the work. Okay, and what about the unit of work?
Joule.
Joule. So what is joule? So what is joule? What do you mean by joule? What do you mean by joule? What do you mean by
Newton.
Okay, so yes. Maybe you already know about it. As you are the final year student, so you have heard work, you have heard about power, you have heard about energy, maybe multiple times, and you already have that idea. Okay, so let me elaborate. If we go back to the same point of work, for example, if you apply 1 Newton of force, you are applying 1 Newton of force to move an object around 1 meter. So if you apply 1 Newton of force, and if you want to move your object to 1 meter from a certain point, that means you are supplying 1 joule of energy. Okay, that means you are supplying 1 joule of energy. So if you apply 1 Newton of force to travel the distance of 1 meter of your object, that means you are spending actually 1 joule of energy. Okay, is it clear to you guys?
Yes, sir.
Okay, so you already know about
Yes,
it,
sir.
and also maybe kind of diagrams maybe you have seen in physics too, and maybe you have seen in your HSC level, right? So if you lift an object, using rope, maybe the object has the mass m, and if you lift this object to the h height, that means your work done will be what? Mass into the distance that you are traveling. I mean the height that you are traveling, maybe h, and also you need to multiply with gravitational constant.
MG.
Right? mgh. Okay, so you already know that. So as you are actually forcing the objects against the gravitational force, in that case you need to actually multiply the gravitational constant, right? That is actually the g. So in this case, if you lift an object to the h distance or to the h heights from a base point, in that case your work done will be what? Mass into gravitational constant into height, right? So you can write your work done will be m into g into h. But if you talk about force, in this case, the force will be, we know F equals to ma, but in this case, as you are working against the gravitational force, in that case, your A will be what? G, right? And your distance D will be, in this case, it will be h, right? Because you are lifting the object maybe from a base point to the above some certain point, okay? So you can write work equals to force into distance that you are traveling. So the unit of force is actually Newton, and the unit of distance is actually the meter. So, okay, so work done will be Newton into meter. And work, the unit of work is actually joule. So you can write joule equals to Newton into meter. So this sort of expressions, symbolic expressions, maybe you have seen in HSC level, right? So
Yes,
all of
sir.
you have seen this, right?
Yes, sir.
Okay. So any question or anything, guys?
No, sir.
Nothing.
No, sir.
Okay, then I can take the viva of you, right? Up to this point.
Yes, sir.
Okay, that's good. Okay, I will take viva. So what you have understand actually. Okay. Let's talk about energy. Okay, so can anyone tell me what is energy? What is the
So
meaning of
কাজ
energy?
করার ক্ষমতাকে শক্তি বলে মানে এনার্জি
Okay. Okay. Anyone else?
ওয়ার্ক ডানের পাওয়ার স্যার, কাজ করার
That means
শক্তি স্যার।
okay. That means you are talking about ability to do some work. That is actually the energy, right?
স্যার
If you want to do some work, that means you need to spend actually the energy. Without spending energy, you cannot apply the force, right?
Yes, sir.
Okay, I'm completely agree with all of your opinion. Anything else? Anything else, guys? No? Okay, so let me share the slide again. So you already told about it, that energy is actually the capacity or ability to do some work. When you have some ability or when you want to do some work, in that case, actually, you need to spend some energy. Okay. So when, as an electrical engineer or as an engineer, when we are talking about energy, that means we are actually thinking about consumption or harnessing of resource. What does it mean? For example, if you have petrol or octane, when you are thinking, maybe you are thinking that, okay, I will apply this petrol or diesel maybe in my engine, right? That means you are actually extracting the energy inside the petrols so that you can actually run your car, isn't it? Or you can actually run your bike. That means you are actually extracting the energy from the petrol, isn't it?
yes
Yes,
sir
sir.
Okay, that means you are actually what? You are extracting the energy. So when you are talking about energy, that means we are talking about extracting something, and also we are talking about consumption. For example, if the power rating of your electricity bulb is 100 watt, what does it mean? That means this bulb requires, in every second, it requires 100 joules of electrical energy, right? That means you are actually consuming the electrical energy. So when you are actually describing the energy, that means you are talking about the consumption, as well as you are talking about the extracting or harnessing maybe some sort of resources. Okay. And in case of coal power station, what do we do actually? In coal power station, we are extracting the energy inside the coal, right? By burning the coal. And then actually we converting this energy to the thermal energy. And finally, this thermal energy is actually, we are applying to the turbine to convert this thermal energy to the mechanical energy. And finally, if the turbine is connected with the generator, that means through this generator, we are getting actually the electrical energy. That means you are actually harnessing the energy inside the coal towards the electrical energy, isn't it? So in every situation, when you are talking about energy, either we are consuming or either we are actually extracting or we are harnessing. Like when we are eating, that means you are consuming or extracting. Which one? When you are eating, that means you are consuming or harnessing.
consuming sir
Consuming, sir.
Sir, consuming, sir.
Then when you are harnessing or extracting. Okay, then it's very difficult to explain now, right? Can be consumption, it can be harnessing. Okay, so আমরা সেটা হচ্ছে জেনারেলাইজ জিনিসগুলোতে থাকি, হিউম্যানের মধ্যে চলে আসলেই it will be much more complex, right?
স্যার হারনেস তখন করতেছি যখন খাবারটা আমাদের ভেতরে স্যার, মানে যখন আমরা ওটা থেকে মিনারেলস, তারপর স্যার মানে পুষ্টি উপাদান নিচ্ছি।
Okay, that means when you are eating, you are talking about consumption, right? But once you take your food and after taking, maybe you are thinking in terms of harnessing, right? Maybe you are collecting
Yes.
minerals, and maybe you are collecting other vitamins from the food. Okay, that's I think quite satisfying answer, in my opinion. What do you think, students?
Yes, sir.
I think
Yes,
the
sir.
answer is quite satisfying.
Yes,
That's
sir.
good answer. So did you try for medical college as well? So you have actually clear
Yes,
idea
sir.
regarding. Okay. So you have actually have the clear idea about human. Anyway, So what are the forms of energy? I already told, right? So there are a lot of forms of energy. So it can be mechanical energy, it can be thermal energy, it can be chemical energy, it can be kinetic energy. Well, you already know about electrical energy, and it can be actually gravitational potential energy. So what is thermal energy? Like if you burn the coal, then you will get the thermal energy, right? And when you are talking about thermal energy, that means we are talking about heat, right?
Yes,
Yes,
sir.
Like the steam engines,
sir.
or let's say you are burning coal, or maybe you are burning the nuclear fuels. Whatever you are burning, that means you are talking about thermal energy. Okay, and also it can be chemical energy. For example, if you talk about fuels. Okay, so different kind of fuels. For example, petrol, diesel. Maybe in the combustion chamber, maybe you are burning the fuel. Okay, before burning the fuel, inside the petrol, it has the chemical energy, right? So inside the petrol or diesel or coal, initially it has actually the what? The chemical energy. Maybe after that, maybe you are taking that coal or petrol maybe in the combustion chamber, and you are firing, then maybe you are getting actually the thermal energy. But before extracting the thermal energy, it has actually the chemical energy. And also inside the batteries, because you know actually in batteries you have anode and cathode, and maybe you have the acids, right? Batteries, if you talk about lead acid batteries, so we have acid, right?
yes,
And
yes.
also we have actually anode and cathode. That means it's the battery is storing the energy in the form of chemical energy, not in the form of electrical energy. It's actually providing you the electrical energy in its output, but when it actually stores energy or dissipating energy, that means it actually dissipating energy or stores energy in terms of actually chemical energy. Okay, and what about kinetic energy? For example, if you move an object, for example, an object has mass m, and if you move that object, that means it has actually the kinetic energy, because you know the definition, I mean the equation of kinetic energy equals to, we know what, half mv square, right? You know the equation
sir.
of kinetic energy
Yes,
is
sir.
what? Half mv square. That means if you take an object, which has mass m, and if you rotate that object with the velocity v, that means the kinetic energy will be half mv square. Okay, যেমন ধরো আমি যদি তোমাকে এখন ধরে যদি ঘুরে ছেড়ে দিই তাহলে কি হবে? So you will gain some kinetic energy, right? And the amount of kinetic energy will be the mass of you and the velocity that I am rotating to you, right?
Yes, sir.
এই কারণে
Yes,
কি
sir.
তাহলে মাথা ঘুরায় নাকি? এই কারণে যে ঘুরতে থাকলে কি মাথা ঘুরায় নাকি? Anyway, so আমরা actually out of scope এ চলে যাচ্ছি. Anyway, so we have actually another type of energy. You already know about it. That is what? The electrical energy. Okay, I will not discuss about electrical energy because maybe you already know about it, isn't it? As you are in the final semester and all of you are going to be the electrical engineer, in that sense you already know what is electrical energy, right? And also
Yes, sir.
we have one more, okay, and another major energy is actually gravitational potential energy. Okay, so gravitational potential energy you will get in the space. Okay, in space you will get the gravitational potential energy. That's why কিন্তু যে পৃথিবী সূর্যের সাথে কিন্তু কখনো ধাক্কা টাক্কা লাগে না, ঠিক আছে? Because it has actually gravitational potential energy. Okay, so these are actually the common forms of energy, and also the energy can be mechanical as well. Can you give me an example of mechanical energy? Can you give me an example of mechanical energy? Anyone?
Sir, motor.
Motor, okay, that's good answer. So in motor you are giving electrical energy, but you are in output you are getting the rotation, right? So as you are getting the rotation, we can call
Yes,
it
sir.
mechanical energy. Okay, that's good. Anything else?
So hydraulics.
Sir, engine.
Sir, hammer.
Hydraulics, okay, good. Engine, yes. Engine is actually converting the thermal energy to the mechanical energy, right? And if you connect the generator to the shaft of
Yes,
the
sir.
turbine, then you are getting electrical energy. But before using the generator in the shaft, you are getting mechanical energy. Yes, that's right. Anything else?
Sir, hammer.
Hammer, okay, that's good. You are applying
Sir,
force by your
windmill,
hand.
sir.
Windmill, obviously. So it is converting the wind energy to the mechanical energy, right? Through the turbine. Then you are getting the electric energy using the generator. Yeah, that's good answer. Anything else?
Riding a bicycle.
Riding a bicycle. Okay. And what about electrical energy? Yes, bicycle is also mechanical energy. What about electrical
Sir,
energy?
generator.
Generator. Okay. And anything else? Well, so you already told many of the mechanical energy, right? So, but electrical energy?
Sir, basically any machine, sir, it's run by
Yes, sir. Washing machine.
electrical energy.
Laptop.
Washing machine, oven,
Okay.
laptop.
Okay, that means nowadays you are actually saying that nowadays most of the appliances, maybe including the big appliances also, including the industries, they are actually using the electrical energy, right, for their purpose. And even metro rail, they will use the electricity.
Yes, sir.
Okay, that's good answer. Anyway, so you already know about it. And
স্যার
what
এখানে
about?
একটা কোশ্চেন ছিল আমার।
Yes, correct.
স্যার আমরা যে ওয়াশিং মেশিন বা মেট্রো রেলে যে আমরা মানে যে কারেন্টে ইউজ করতেছি ওটাকে আমরা ইলেকট্রিক্যাল এনার্জি বলতেছি, বাট জিনিসটা এরকম না স্যার। মানে আমরা ইলেকট্রিক্যাল এনার্জিটাকে ইউজ করেই তো স্যার মানে একটা যে কোনো একটা শক্তিকে ইউজ করতে আর একটা ফর্মে মানে ট্রান্সফার করতেছি। লাইক ওয়াশিং মেশিনে তো আমার যখন ঘূর্ণন মানে ভিতরে যেটা কাপড়টাকে ওয়াশ করে ওটার সাথে যদি ঘূর্ণন না হয় তাহলে তো স্যার আমার কাপড়টা ওয়াশ হবে না। সো স্যার আলটিমেটলি এটা কি মেকানিক্যালে চলে যাচ্ছে না?
Right, in mechanical. That means from electrical energy, you are converting to the mechanical energy. So it has blades, right? It has blades
sir.
so that the motor can make some spin of the water. So if you want to make the spin in the water, that means you need some sort of maybe turbine or maybe some sort of blades. That is actually available inside the washing machine.
জি স্যার।
Okay. And in case of metro rail, so it has actually induction motor.
জি স্যার, বুঝতে পেরেছি।
The electricity actually you are providing to the induction motor, and induction motor is connected with the wheels, right? Wheel of the metro
জি
rail.
স্যার, বুঝতে পেরেছি।
Then you are getting the rotation. And most widely, actually, as far I know, they use actually an induction motor because induction motor is lightweight. It is actually compact, and also it requires actually minimum maintenance because it has no brush, right? It has no carbon brush or no commutator is required. That's why maybe induction motor is most widely used in metro rail. I'm not sure whether they actually use any other type of generator or sorry motor, but as far I remember, if I'm not wrong, they use actually the induction motor. Okay, so let's talk about power. So you already have the idea about power, right? So what is power?
Yes, sir.
So power is actually the rate at which the energy that you are talking is converting from one form to another. That means if you convert from thermal energy to mechanical energy, or mechanical energy to electrical energy, or electrical energy to thermal energy, at which rate you are converting actually. The rate that you are converting from one form of energy towards another form of energy, that means you are talking about power. For example, I already gave you the example, that is, if you talk about 100 watt of bulb, what is the meaning of that 100 watt of bulb? The meaning of 100 watt of bulb is like it will convert in every second 100 joules of electrical energy to the light, as well as it will generate heat, right? So when it will go inside the filaments, when the filaments will glow to produce light, that means it actually also produces heat, isn't it? That heat is actually we can call it's a waste actually, right? So our motivation or our objective is to get the light, not the heat. But when you produce the light from a incandescent bulb or any sort of bulb, you will get actually the heat, right, from the bulb. So the unit of power you can call as watt, and watt 1 watt equals to 1 joule divided by 1 second. That means, can you tell me what is the meaning of 100, maybe 200 watt of fan? What is the meaning of 200 watt of fan? Can anyone
স্যার
tell me?
প্রতি সেকেন্ডে স্যার 200 জুলস ইলেকট্রিক্যাল এনার্জি
ঘোরানোর জন্য 200 জুল
ঘোরানোর ইলেকট্রিক্যাল এনার্জির প্রয়োজন।
Okay, so exactly. So on every second, it will convert 200 watt of electrical energy to the mechanical energy, right? And also it will produce some heats as well. So every device, they produce heat, right? every device they actually they will work, but they will also produce the heat. Okay, that's why you required maybe some sort of cooling mechanisms. Maybe you required actually the heat sinks, right? Okay. So another thing is, like, if you talk about the electrical heater, let's say the electrical heater has the capacity of 1 kilowatt and it's running for 1 hour. Okay. Then in that case, how much of energy it's actually consuming? Can you define how much energy it will consume? So it will consume, its capacity is 1 kilowatt, it's running for 1 hour. That means 1 kilowatt, we already know 1 kilowatt equals to 1000 watt, right? And that means 1000 watt means 1000 joule per second. That means in every second, it's actually consuming 1000 joules of electrical energy. And if you convert 1 hour into the second, then it will be how much? 3600 seconds, right? So 1 hour equals to what? 60 into 60 now? 60 minutes into 60 seconds. That means total it will be 3600 seconds, isn't it? Students?
Yes, sir.
Yes, sir.
So in that case, this electric heater, if you run for 1 hour, that means it's consuming actually 1 kilowatt hour of energy, right? So 1 kilowatt hour of energy equals to, you can write 1 kilowatt equals to 1000 watt, multiply by 1 hour means 3600 seconds. So in total, it's actually making 3.6 into 10 to the power 6 joules. That means it's consuming actually 3.6 megajoule, isn't it? So you required 3.6 megajoule of energy if you run your electric heater, which has the capacity of 1 kilowatt, and if you run this electric heater for 1 hour. So if you run this electric heater for 1 hour with a capacity of 1 kilowatt, that means this electric heater is actually consuming 3.6 megajoule. Is it clear to you? So you already maybe learned this sort of things maybe in electrical circuits 1. I'm not sure whether you have learned or not, but these are the things maybe included in the electrical circuits, right? Okay. Okay, so most commonly used actually the units are, joule is actually the smallest unit. Okay, so when you are talking about power system, that means you are talking about multi-megawatt, right? Normally the capacity of the power station are expressed as what? Megawatt, right? Maybe 20 megawatt, yes, maybe 50 megawatt. So আমাদের তো সবগুলো মেগাওয়াটেই রিপ্রেজেন্ট করা হয় নাকি? So that's why actually when you are talking about renewable energies or can you hold for a second? I got a Okay, I have got a call from BTI. BTI is a building company, right?
Yes, sir.
Okay, I don't know. Okay, I don't know why they have called me. I'm a poor guy.
Sir,
So
they're probably trying to sell you an apartment.
But I am a poor guy, so how can I buy actually apartment?
Sir, they called me the other day. An apartment.
Okay, so you also got the call.
Yeah, sir.
So they maybe collect the data from where? Maybe Grameenphone or maybe the mobile operator provided them the information.
No idea, sir. No idea.
Okay. Anyways, so actually this is the scenario. Even I never actually ordered from Chaldal. Always my wife, she actually involved with Chaldal and Food Pandas and Daras and everything. Okay, but I got messages regularly from Daras.
Yes,
maybe
sir,
from
they track the location, sir, and they
Yes,
like
sir, same here.
অ্যালগরিদম করে স্যার ওদের লোকেশন অনুযায়ী এরকম নাম্বার যেগুলো এক জায়গায় থাকে ওগুলো টেক্সট আসতে থাকে একই ধরনের আপনারা ইউটিউবেও দেখবেন স্যার
Okay, but I never give any order. Okay, my wife actually always, Dr. Ifat, she actually always ordered everything, and I don't know why I get the message. Maybe you are right, they are tracking my locations or anything. Anyway, so let's come back to the topic. So when you are talking about power systems, so we are actually thinking about some actually higher units. For example, kilojoule. If you talk about kilojoule, it's 10 to the power 3. Megajoule, it's 10 to the power 6. So joule is actually the smallest unit. Okay. gigajoule, terajoule. Actually, we utilize this kind of thing. So currently in our power system, in Bangladesh, most of the power stations or the total capacity or the total generation we are expressing in terms of what? Megawatt, right?
Yes,
We
sir.
are talking about megawatt. Maybe we need 20,000 megawatt. But near future, maybe in 2050 or maybe 2060 or maybe 2070, when we'll get actually many production or many generation, because our population is growing and also our economy is growing. So maybe we'll require actually maybe 50,000 or 60,000 or even higher power generation. So in that case, maybe they will use gigawatt, right? Even some countries, they express their generation in terms of gigawatt. Okay, now we are expressing in terms of megawatt, but when we'll have actually the higher capacity or higher generation, in that case we will also use actually the gigawatt or maybe terawatt of capacity. Okay, so we already discussed 1 kilowatt hour equals to, we know, 3.6 megajoule. And okay, so what about the BTU? So if you express the BTU in terms of joule, that means 1 BTU equals to 1055 joule. Okay, so you can tell 1 BTU equals to 1.055 kilojoule. Okay, so 1 BTU equals to 1.055 kilojoule. Is it clear to you? Is it clear to you?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So let's talk something funny. Let's talk something funny. So let's say you just take a cup of coffee. So if you take a cup of coffee from Starbucks, so you are actually consuming 60 kilocalories of energy. So is there any outlets in Bangladesh of Starbucks? Maybe no, right?
No, sir.
So if you take a cup of coffee, maybe in the foreign countries from the Starbucks, you will get around 60 kilocalories of energy. Okay. And if you take a Snicker bar, so it has actually 280 kilocalories of energy. Okay. So if you take a Snicker bar, you will get around 280 kilocalories of energy. So that means if you take a cup of coffee and if you take a Snicker bar together, you will get around how much kilocalories of energy? Maybe you will get 280 plus 60 equals to 340 kilocalories of energy, right?
Yes, sir.
If you consume a coffee and if you consume a Snicker bar, so you will get around 340 kilocalories of energy. Okay. So that means if you convert, we know actually 1 kilocalorie equals to what? 4.2 kilojoule, right? 1 kilocalorie equals to, students? So 1 kilocalorie equals to 4.2 kilojoules. That means if you convert this 340 kilocalories into the kilojoules, that means you are actually 340, the meaning of 340 kilocalories is actually 1428 kilojoules, right?
Yes, sir.
Is it clear to you?
Sir.
Yes,
Yes,
sir.
sir.
Okay, so let's talk about the energy that you are consuming when you are actually concentrating on my lectures. So there is actually a research. So if you just listen to lectures for 1 hour, that means you are consuming or you are taking around 120 watt of energy. Is it clear to you?
Yes, sir.
Yes, sir.
So if you are concentrating on my lecture for 1 hour, that means you are consuming or you are expecting how much of energy? 120 watt of energy. And you know 1 watt equals to 1 joule per second, right? That
Yes,
means you required in every second 120 joule of energy. Okay, in every second, if you want to study my lecture or if you want to listen my lecture or any kind of lectures, that means you are actually consuming in every second 120 joules of energy. And it is actually an assumption that you are still concentrating on my lectures. You are not moving your hand, or maybe you are not moving your head or neck or anything. You are just listening to my lecture. Okay. So that means if you are sorry, maybe I did a mistake. So you required in 120 watt. That means every second you required actually 120 joule of energy. For 1 hour, you required what? 120 into 3600, right? So this is for every second. In every second, you required 120 joule. Then in every hour, that means you required around 432 kilojoule of energy, right? So for 1 hour lecture, you required 432 kilojoule of energy. And from the coffee and Snicker bar, you got around 1428 kilojoule of energy, right? So that means if you take a cup of coffee and Snicker bar, then my question is, how many hours you can listen to my lecture? How many hours you can listen to my lecture? Well, you need to simply do the ratio, right? So for 1 hour lecture, you record 432 kilojoule of energy, and available, you already got the energy from the Snicker bar and coffee, that is 1428 kilojoule, right? So that means if you do the ratio, by taking a Snicker bar and by taking a coffee, you can actually concentrate on my lecture for 3 hours and 80 minutes. You can try, right? So, so from the Snicker bar and from the coffee, you can concentrate around 3 hours and 18 minutes of lecture. Is it clear to you?
Yes, sir.
Yes, sir.
Yes,
Yes,
But
sir.
this coffee must be from the Starbucks, and this Snicker bar must be the original Snicker bar. If you take a Snicker bar from Puran Dhaka, it will not work. It will not give you 280 kilocalories, even though the color of chocolates and the water color of Burigongas are similar, right? So if you take some water and maybe you take some nuts and maybe you take some cocoa beans or chocolate beans, and then if you make the Snicker bar, so it will not give you 280 kilocalories of energy. Okay.
Yes, sir.
It will give you jaundice.
If it will give you jaundice. Okay, we'll discuss. And before that, let's take a short break of 10 minutes. Okay.
Okay, sir.
Let's take a short break of 10 minutes, then we'll discuss again. Okay, students, are you listening? Are you listening?
Yes, sir. Yes, sir.
Okay, so as I told, the sneaker bar should be the original sneaker bar. Okay, পুরান ঢাকা থেকে ওই যে ওই পানি দিয়ে কিন্তু স্নিকার বার খাইলে কিন্তু হবে না। সো বাংলাদেশে এটা একটা সমস্যা। আমাদের এখানে আমি জানি না আমাদের এখানে সুন্দর সুন্দর চকলেট কেন বানায় না, সব বিদেশ থেকে আনতে হয়। এন্ড যেগুলো পাওয়া যায় তোমার ওই যে ডিসিসি মার্কেট বা হচ্ছে এই যে তোমার কোথায় জানি হোলসেল, রাইট, এগুলোতে কিন্তু ভালো এক্সপেন্সিভ আর কি চকলেট গুলো। এন্ড প্যাকেট গুলো দেখছো না কেমনে কেমনে হয়ে থাকে, কবে নিয়ে আসছে না নিয়ে আসছে কোনো ঠিক ঠিকানা নাই প্যাকেটের, isn't it?
Yes, sir.
Okay.
Sir.
Tahle, let's back to the lecture again. So, well, you already have the idea of what is renewable energy, okay? So, it has actually many definitions of renewable energy. I have put it around 5 definitions over here, but most of the definitions, I mean, not most of the, every definition are actually saying the same thing, okay? Same thing. So, what is renewable energy? So renewable energy is like the energy that you are getting from the environment. Well, you can maybe tell, okay, sir, I'm also getting coal from the environment. Okay, but there has some difference. Okay, the renewable energy you are getting from the environment, and also it repeatedly, it actually refills the environment continuously. For example, if you take the coal or if you just extract the natural gas, then maybe if you extract, then it will finish, right? But what about wind and solar? So if you take wind today, tomorrow you will get the wind or not?
Yes, sir.
So tomorrow you will get the wind at the same rate. So that's why it's actually continuously or repeatedly, it's actually refill in the environment. But if you talk about the fossil fuels, if you take, you are getting from the environment, that's true. But once you have collected or extract that coal or maybe the diesel, so it will actually finish. And most importantly, the renewable energy you are harnessing for the human benefits, okay? It do not have any air pollutions or any harmful impact, okay? And second definition is also same. You are getting the renewable energy from the environment and it doesn't have any actually environmental threats as like the fossil fuels or like the nuclear power station, that is uranium, okay? So every definition are actually the same thing. So energy flows which are replenished at the same rate that are used. So it will be refilled automatically at the same rate that you are using. For example, if you, as I told, if you extract coal, it will finish. So next day কিন্তু তুমি কোনো coal পাবা না, পাবা যে পরিমাণে extract করে ফেলছো মানে করে ফেলছো। But in case of renewable energy, it's not like that, okay? Well, there is one important line, that is most of the energy source actually coming from the sun. Even wind you are getting from the sun. If there is no sunlight, you will never get any wind. Do you know that? আমরা যদি sunlight না থাকতো, then actually you will never get any wind, okay? And also everything, every energy that has actually the that is coming from the sun. এই কারণে খুব ancient এই যে তোমরা যে শুনছো বিভিন্ন সোশ্যাল কালচার বুকসে, তো ওরা কিন্তু সূর্যকেই কি মনে করতো সকল কিছুর শ্রেষ্ঠ থিং, তাই না?
Yes, sir.
Because it has actually the source of power. So it is actually driving the I mean the earth, I mean every energy or even the earth rotation you are getting because of the sunlight. So if there is no sunlight, you will not get any earth rotation, okay? So let's talk about non-renewable energy. Well, you already have the idea. What are the non-renewable energy? For example, nuclear, for example, coal, for example, oil, for example, natural gas. These are actually your what? Non-renewable energy. So what is that standard definition of non-renewable energy? So non-renewable energy, you are actually getting the non-renewable energy from the static stores of energy, okay? What is the meaning of static stores? For example, if you do not extract any coal, then it will be remain bounded, right? তো তুমি যদি কয়লা ওইখান থেকে যদি না নিয়ে আসো, কোল যদি না নিয়ে আসো, তাহলে ওটা কিভাবে থাকবে? স্ট্যাটিক অবস্থায় থাকবে না? যেমন তেল যে মাটির নিচে কি অবস্থায় থাকে, স্ট্যাটিক অবস্থায় থাকে না, কার সাথে রিঅ্যাকশন করে?
No, sir.
Okay. In order to use those energies in the coal or maybe in the petrol or maybe in the diesel, so you need actually human interaction to unbound actually or to extract actually. So you need actually human interaction or the machine interaction to extract coal, or actually the fossil fuels, for example, uranium, or actually the petrol or diesel. That means you need actually the human interaction, and you need to extract those energy actually. This is actually the standard definition. So it will be remain as static, and when you will give actually the human interaction, in that case you can actually utilize the non-renewable energy. So what are the examples of non-renewable energy? Well, all kind of nuclear fuels, for example, uranium, and fossil fuels as well. For example, coal, oil, natural gas. So this every sort of energy that is actually the non-renewable energy. So non-renewable energy, if you talk about the characteristics, so initially this energy will be isolated, right? As I told already. So you need actually the what? External action or the human action is required, right? Without human interaction or machine interaction, you cannot actually extract the non-renewable energy resources. And also, most importantly, the non-renewable energy, we called it as finite supplies. Why it is called finite supplies? Why it is called finite supplies?
Because sir, it is available in nature.
It will finish one day, right?
Yes, sir.
It will finish one day. It's limited. That's why it's called the finite supplies. Okay. Well, so you already have the idea why we need the renewable energy, right? Because non-renewable energy resources are limited. This is true. Once you use the non-renewable energy, so it will finish one day. That's why it's limited. Number two motivation, renewable energy has supply security. What does it mean? For example, let's say you have some bad relation with Middle East. In that case, will you get any fuel in Bangladesh? Let's say we have some clash. We have some clash. Just imagine we have some clash with the Middle East or maybe some other countries, those who are producing or actually giving us the fuel. So in that case, will you get any fuel if you have a bad relation? You will not get any fuel, right? In that case, you cannot say that those non-renewable energy resources have supply security. So it has no supply security. Once you make any bad relation with the maybe the producer, in that case you will not get any not get any non-renewable energy resources. That's why it has no supply security. But what about non-renewable energy? Are you paying someone for sunlight? Are you paying someone for wind? No, right? You are not paying for sunlight. You are not paying for the wind, right? That means it has supply security. And also it will ensure sustainability. So what is the meaning of sustainability? In Bengali, we call tekshoy, right? So if we talk about the standard definition of sustainability, that means the definition of sustainability is like you are meeting the need of present generation without compromising the ability of future generation. What does it mean? Let's say you are using the wind today or sunlight today. In the next day, you will get the sunlight or wind in the same amount. That means you are utilizing today as much as you can. Also, you are not compromising the future generation for maybe for the tomorrow. This is actually the definition of sustainable energy. Okay, so my question is, can you say energy is a sustainable energy? Yes, it's a sustainable energy. Why? In order to fulfill the requirement of sustainable energy, it should have three characteristics. What are the characteristics? Number one, is not substantially depleted by continued use. So if you continuously use, it never decay, right? It will never actually decay, or it will actually never depleted. তোমার এটা কি কখনো শেষ হয়? Okay, so number one condition is satisfied. In that sense, we can say our renewable energy is sustainable energy. Second condition is it should not produce, or it should not pollutant, or it should not generate any sort of, harmful gases, or it should not make any problems to the environments. So does renewable energy have any problem with the environment or maybe generating pollutions? No. So second condition is also justified. And the third condition is it should not actually create any health hazards or any social injustice. So does renewable energy have any health hazards like nuclear power station? No, right? It's environmental friendly. And also it doesn't have any social injustice. Let me give you an example. Let's say our government is actually planning to actually implementing a coal power station in Rampal, right, in near the Sundarban. So it has a lot of debates, isn't it? Whether it's a matter of question that whether it is suitable or not. But if government plans to install the renewable energy in the same place, in that case, will you get any debate? Or will you get any maybe talk show? No, you'll not
No,
get
sir.
any debate because it's actually the environmental friendly. That means non-renewable energy, or if you consider energy as a sustainable energy, it should not have actually the social injustice or health hazards. So these three conditions actually satisfied by renewable energy. That's why we can say our renewable energy is a sustainable energy. Okay, is it clear to you?
Yes.
And your renewable energy actually maintains sustainability in terms of energy, in terms of environment, in terms of society, as I already described, and it will actually improve, or it will actually boost up your economy as well. Okay, because once you install the renewable energy, you do not require to buy any fuel, or maybe you do not require to extract any coal. So in that case, actually, you can boost up your economy as well. Is it clear? Okay, so let's talk about some advantages of renewable energy. I believe you already have the idea, right? For example, you can get the renewable energy in our earth in an abundant amount. That means you are getting the renewable energy resource, for example, wind or sunlight, in a huge amount. This is actually the primary advantage. Number two is actually you do not require any fuel cost, right? Because you are not using any fuel. And also it has actually lower environmental impact if you compare with the conventional fossil fuels or nuclear fuels. That in that case, actually the environmental impact is very less. And also it has actually low emission of greenhouse gases. Okay. And also you can implement this kind of power station or renewable energy based power station in a very short time. For example, if you consider the nuclear power station, it requires maybe 15 to 20 years, right? And we heard about Rupur power plant in our childhood, and still now it's actually government is installing. That means actually the installation time is very high for the conventional power plant. But if you consider about renewable energy source, maybe it requires maybe 1 year or 2 year maybe. Okay, and also it is very much suitable for the remote locations. For example, if you want to install any wind turbine or PV system in the remote locations, for example in Hatia or maybe in Shondip or maybe in Saint Martin. So this sort of power station based on renewable energy is very much suitable. And also if you talk about the biogas or biomass, that means you are generating electricity from what? From the household waste materials. So the municipal waste that you are getting in your house, from that municipal waste you are actually generating the electricity. So these are actually the primary benefits or the merits of the renewable energy. Let me ask you one question. So, does renewable energy have any disadvantage? Is there any disadvantage with the renewable energy? So, renewable energy has any disadvantage, guys?
স্যার পরিমাণটা কম যেটা উৎপন্ন হয়
Well, it can be treated as a disadvantage. Very good point.
So
Anything
maintenance
else?
cost বেশি
Maintenance cost will.
So time লাগে মানে স্যার
Okay.
process time.
That means if you want to get the system payback or actually the benefit from this investment, it takes longer period of time, right?
Yes, sir, time.
Well, this can be, yeah, this can be treated as also a disadvantage. Okay, let me elaborate with your explanations. So many, well, you know, the renewable energy sources are intermittent. What is the meaning of intermittent? Intermittent means maybe in the morning you are getting very few amount of sunlight. Maybe in the afternoon it's actually the same scenario. Maybe in the noon period, maybe from 12 p.m. to 3 p.m. you are getting high amount of radiance. The wind speed is also fluctuating. So if your wind speed or sunlight are fluctuating, in that case the output will be also fluctuating, right? The output, that means the power that you are getting from that that will be also fluctuating. Okay, this is one of the disadvantage. What about the next one? Next one is, if you talk about the major disadvantage, so it requires actually the backup system. For example, now if you consider the Dhaka city, the climate is actually cloudy. Okay, so due to this cloudy condition, you will not get any irradiance. So in that case, your solar system is totally shut down. So if you want to get the power from this sort of power station, you need what? Maybe the backup, maybe the diesel generator as backup, maybe the what? Maybe the other sort of sources as backup, right? তো আমাদের যদি এখন রিনিউয়েবল এনার্জি সবগুলো যদি কানেক্ট করি, এখন যদি বন্ধ হয়ে যায়, সানলাইট যদি বন্ধ হয়ে যায়, in that case you will get the load shedding or you will get the power blackout. But normally তো এটা হয় না. That means every power system they have actually the backup plan, right? So this is actually one of the disadvantage. You require actually the backup system, and also you require the energy storage. As I told, in the night time you will not get any electricity from the PV system. But what you can do, you can store actually the energy extracted from the PV system to the battery system, right? So if you actually store some portion of your PV generation in the battery, in that case you can use in the night time. But remember one thing, if you add extra items or any extra devices in your power system, in that case what will happen? Your system cost will increase, right? This is one of the disadvantage. And another disadvantage, renewable energy, if you consider the renewable energy, it will take actually large amount of space. Okay, and also if you talk about the wind turbines, sometimes they produce noise. Okay, so this noise is harmful for the maybe for the insects or maybe for the birds. It's actually harmful. And sometimes for the hydropower station, if you create some dam or if you create some obstacles in the river, in that case you are actually it's actually harmful for the fish, for the flora and fauna. মানে পানির নিচে যে ছত্রাক থাকে, শৈবাল থাকে, এগুলোর জন্য কিন্তু তুমি যদি বাদ যদি দাও, মানে অবস্টাকল যদি ক্রিয়েট করো, it will actually hamper their life, right? মেরিন লাইফটাকে আমার কি করবে? ফিশ লাইফ বা ফ্লোরা ফৌনা যেগুলো থাকে সেগুলো কিন্তু আমার ইমপ্যাক্ট কিন্তু নিয়ে আসবে. Is it clear to all of you?
Yes, sir.
Okay, so what are the renewable energy sources? Well, you already know. So there are a lot of types of energy sources. For example, wind energy, it can be hydro energy, it can be solar energy, it can be geothermal, it can be bioenergy. So wind energy, basically two types. One we call the offshore and another one is onshore. For example, if you connect all your wind turbines in the mainland, that means it's called onshore wind turbine. And if you connect all your wind turbines, maybe inside the sea, that is called offshore wind turbine. So this kind of offshore wind turbine, you will see a huge amount in Europe, Europe actually, in UK, maybe in Denmark, maybe in Sweden, you will see a lot of offshore wind turbine. And also if you go to the Australia, you will see a lot of wind turbines that are installed inside the sea, okay? Because there is one advantage compared to onshore, that is in the offshore, in the sea, you will get high speed of wind, right? And also solar energy nowadays, it's called floating. What does it mean? China and Singapore, they have installed the PV system in the sea. Have you seen it? Have you seen it?
Yes, sir.
The solar panels are the solar panels are installed inside the sea. Okay, so it's called actually. Can you mute? Maybe I'm getting some noise. If I request you to respond, in that case again, please respond. Okay. Otherwise, please mute your microphone. So solar energy nowadays, it's actually the floating solar power plant, especially in Singapore, and also I have seen in the newspaper in China, they are installing the solar PV system in the floating conditions, maybe in the sea. And maybe, who knows, near future, you will see it in Bangladesh as well. Okay. Okay, so let's talk about some statistics. So back in 2010, the renewable energy shares are actually 16.7%. So maybe currently it's around more than 20%. And also, this is the scenario back in 2016. So these are actually the total uses of renewable energy and fossil fuels power station. And still fossil-based power station are in dominating position, okay? But maybe by 2030, by 2040, maybe you will see this fossil fuel percentage will be 50%. You get my point? Due to expansion of renewable energy and penetration of renewable energy, maybe in near future you will see this penetration is actually around 50%. Okay, so let's talk about some other statistics. For example, if you look at the renewable energy starting from 2007 to 2017, you can see this is actually the growth of hydropower. Hydropower is almost constant, right? Almost constant. But wind turbine, you see, it's actually expanding, right? And solar is actually also expanding. But you can see the expansion rate of wind and solar are not same. So which one is higher in terms of expansion? Wind or solar? So wind has the much more
Wind, sir.
expansion.
Wind.
If you talk about the worldwide, so wind expansion is higher. Why the wind expansion is higher? Because the primary benefits of wind turbine is you can get electricity for 24 hours. But in case of PV panel, maybe you will get the electricity for 9 hours because the sunlight maybe last for 8 to 9 hours. Maybe starting from 8 a.m., you will get the sunlight maybe 8 a.m. to 5 p.m. But if you consider the wind speed, you are getting for maybe 24 hours, right? This is one of the primary benefits. And another benefit is nowadays from a single wind turbine, it is actually possible to generate around 10 to 15 megawatt of power. So if it is in rated condition. So if it is in rated condition, from a single turbine, it is very much possible to actually generate around 10 to 15 megawatt of electricity. But if you want to generate 10 to 15 megawatt of electricity using the solar panel, in that case, you will maybe require 2 or 3 AAB football fields. So you require 2 or 3 football fields, then you need to install all your PV panels, then you will get actually 10 to 15 megawatt of capacity. But a single wind turbine will give you around 10 to 15 megawatt. These are the two benefits. That's why actually the world is moving towards the wind turbine compared to PV system. Okay. And currently the renewable energy penetration is around 2,195 gigawatts. Okay. And this is actually one more statistics. So in 2017, the renewable energy based on solar, it was actually 402 gigawatt, but wind turbine expansion was 539 gigawatt. Okay. And these are the top 10 countries in renewable energy. Well, as expected. So Denmark, you see, if you consider their total generation, out of the total generation, more than 55% are coming from where? From the renewable energy, isn't it? And more than 50% are coming from, as expected, from the wind turbine. Because in Denmark, there are a lot of wind turbines. Maybe you have seen, maybe in the movies, maybe in the YouTube, you have seen, right? In Denmark, there are a lot of wind turbines.
Yes, sir.
So if you consider their total generation, out of the total generation, they are getting around more than 50% just using the wind turbine. And I went to Denmark back in 2018 for a conference. And I have heard that Denmark is planning to run on 100% renewable energy, maybe by 2035. Okay, by 2035, you will see all of the generation will be based upon the renewable energy. Currently, it's around 55%. Okay, and more than 50% they are getting from the wind turbine. And Uruguay, they have also actually a lot of wind turbines compared to solar. Germany has a lot of wind turbine, and also they have solars. And Ireland's are actually also dominating in wind turbine market. And also maybe they have very flat line for the PV system. And Portugal also have, actually in Europe, you see, in Europe actually they have a lot of wind turbines, okay? And Honduras also less wind turbine compared to PV system. And Nicaragua, they have actually a lot of wind turbines. Do you know where is Nicaragua? Nicaragua, have you heard the name?
Africa, sir?
Africa? Okay, I'm not sure. I'm not sure where it is. It's maybe near the, actually, in between the North America and South America, right? Maybe it's actually an island. I'm not sure. Maybe near the Jamaica or maybe near the West Indies. I'm not sure.
Central America, sir.
Central America, okay. So they have actually a lot of wind and solar panels. Okay, if you talk about the jobs in renewable energy, well, so there are a lot of jobs because if you want to integrate renewable energy in the national grid, you cannot integrate it easily. Before integrating, you need to solve a lot of issues. For example, efficiency is a concern, the power quality is a concern, the voltage and frequency are the concerns. So if you consider all these scenarios, there are actually a lot of jobs are available, even in Bangladesh. Okay, this sector will dominate around 20 to 30 years because so trying to install the renewable energy, right, in Bangladesh. But we have actually many obstacles. For example, we have actually a huge amount of population. This is actually an obstacle. Second obstacle is like we are not getting a promising value of wind speed. Okay, our is not actually the in promising condition. So these are all actually the drawbacks. But as an engineer, but as a researcher, you need to overcome all these barriers, right? So that's why actually there are a lot of job scope if you consider in Bangladesh and also in outside, and including there are a lot of scholarships are available in this field. Is it clear to you?
Yes, sir.
Okay.
Yes,
So
sir.
let's talk briefly about solar energy and solar thermal system. So we will discuss in depth maybe in third lecture or fourth lecture. But solar energy, you can see the equivalent solar energy that is actually you will get inside the sunlight around 160 times of the stored world's proven reserves of fossil fuel. The amount of fossil fuel, that amount with 160, this amount of energy is actually present in the sunlight. Isn't it a huge amount? It's a very huge amount, right? 160
Yes,
times.
sir. Yes,
And
sir.
also you are getting, if you consider all your fossil fuels and nuclear fuels and hydropower, and if you multiply that amount, I mean total consumption amount with 15,000 times, so this amount of energy will be present in the sunlight. So it's a very huge amount. So you have around 160 times of the total fossil fuel that you have, and you will get around 15,000 times of the total energy that you are consuming from the fossil fuel, nuclear fuels, and hydropower. So it's a very huge amount. Okay. And what is a solar thermal system? So we will learn it in detail in the laboratory as well as in the theory class. So for the time being, solar thermal collector has tubes. Okay. Inside the tubes, we are flowing the fluid. For example, if you flow the water and if you are actually taking the sunlight, then what will happen? The fluid or the water inside the tube will be heated up, right? Isn't it? So it will collect the heat from the sunlight, and eventually your fluid or the water inside the tube will be what? Heated up, right?
Yes, sir.
And at some point, this heated water will be converted to the steam, isn't it? So if it is converted to the steam, then if you connect a turbine and a generator, then what will happen? You can actually rotate your turbine using this steam, and if you connect a generator in the mechanism of solar thermal system, that means that the tube you have, so inside the tube there is actually fluid or water. So when it actually collect the sunlight, the solar irradiance, in that case your water or maybe the fluid will be heated up, and it will actually convert it to the steam, and your steam will be actually rotating your the turbine that you have, the mechanical turbine. And eventually from the turbine, if you connect a generator, then you will get actually the electricity. Okay. So this is actually the basics of solar thermal system. And what about solar photovoltaics? So in case of solar photovoltaics, you are converting the sunlight directly towards the electricity. But this solar thermal system, we are calling it as indirect conversion. Why it is indirect conversion? Because you cannot generate electricity directly, right? So you need to convert to the steam first, then you need to convert this steam to the mechanical energy, and then using generator, you are converting that mechanical energy towards the electrical energy, right? That's why the solar thermal system is called indirect conversion. But if you consider the solar PV system, that means you are converting the sunlight to the direct electricity. Did you get my point? So if you have the PV system, so it has PN junctions. So when the light falls to the strike, so the electron and hole pairs will be generated. And from that electron and hole pairs, you are getting the electricity. That means this is the direct conversion. So you do not require any generator or anything. Okay. And if you consider the efficiency, well, the solar PV efficiency is around 24%. So we will learn all of these things maybe in the last lecture of midterm, maybe the last lecture or second last lecture of midterm. Okay. And commercially available, most of the PV cells have the efficiency falls around 14 to 15%. Okay. And there has actually 4 definitions. One we called irradiance, another one we called irradiation, another one insolation, and another one is irradiance. So irradiance is measured is actually about the sunlight in watt per meter square. Just consider 1000 watt per meter square. What does it mean? in every meter square of area, 1000 watt. Did you get my point? The meaning of this irradiance is in every meter square you will get how much amount? 750 watt. Okay. And what about the okay, guys, are you listening?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
So
Yes, sir. Yes, sir.
I need around maybe 1 or 2 minutes. Okay, I need around one or 2 minutes. And what about irradiation? So irradiation is measured in joule per meter square. So it's actually in every meter square the energy that is inciding. So if you consider the watt per meter square irradiance, you can compare with power. Okay, it's actually comparable with the power, and irradiation is you can compare with the energy. So energy is actually kind of irradiation, and power is kind of irradiance. Okay, and another term we have that is insolations. Okay, so when you are actually expressing any sort of solar energy irradiation, then actually we are expressing it in terms of insolation. Okay, so this is not insulation. This is insolation, insolation, insolation. Okay. And last thing definition we have for today, that is we call the radiosity. What is radiosity? Radiosity meaning the rate at which the incident energy is leaving the surface. For example, if you get the solar irradiance on a surface, will you get all the energy from the sunlight? So some of the energy may be scattered or reflected back, right? তোমার একটা কোন একটা সারফেসে সানলাইট পড়ার পরে কিছু এনার্জি কি হবে রিফ্লেক্ট ব্যাক করবে না বা স্ক্যাটার্ড হবে না
Yes.
so that amount of energy we are calling it as radiosity. Okay, so just learn these 4 definitions. Okay, and these are the reference that I have followed for this lecture. Okay, so that's all actually. Any question you have? Any question you have in your mind? No question?
No, sir.
No, sir.
Sir,
Okay, so you want to, yes. You
sir,
want to leave the
ultimately,
class?
sir, ultimately, renewable energy টা তো তাদের জন্য স্যার ব্লেসিংস যাদের মানে উইন্ড পাওয়ার স্ট্রং, তারপর হচ্ছে সানলাইট বেশি পাচ্ছে লাইক ইউরোপ, তারপরে হচ্ছে যারা নর্থ ইস্ট সাইডে আছে ওদের জন্য স্যার এটা ব্লেসিংস, বাট আমাদের জন্য তো আলটিমেটলি, কারণ আমরা তো জলবায়ুটা তো আর কারো হাতে নাই, সো ওটা তো আমাদের দিকে তেমন মানে ওরকম ইম্প্যাক্ট ফেলতেছে না।
Okay, I got your point. But if you consider the weather condition in Bangladesh, so we are getting around a good amount of sunlight. Okay, this is actually the statistics. So in Bangladesh, there are actually huge potential of sunlight, and also there is potential for wind turbine as well. So NREL, there was a company, so they have actually did a survey, and based on the survey, they have decided in Bangladesh maybe they have got around 13 potential areas where they can install the wind turbine. Okay, near future you will see the wind turbine in Bangladesh as well as we already have around 300 plus megawatt of solar PV system in Bangladesh. And the recent addition maybe in Moimenshing, you already know. So in Moimenshing, we have got around 50 megawatt of PV power station. So is there anyone from Moimenshing? Is there anyone
Yes,
from
sir.
Moimenshing? Okay, so in Moimenshing farm, right?
Yes, sir.
It's near the maybe the Brahmaputra node, right? So you have Brahmaputra node in Moimenshing?
Yes. Yes, sir.
Okay. At the bank at Brahmaputra, you will see a lot of the power station based on PV, and maybe wind will also come by 2030. Okay, that's why actually there is huge scope for research, for jobs in this field. Any more question? Okay, so if you do not have any question, I would like to conclude. I hope to see all of you in Wednesday. No, we'll see in Sunday, right?
So next Sunday.
Next Sunday. Okay, so in that case, I'd like to conclude. I'd like to thank all of you, and don't forget to send me the group members' name as I instructed already before the next lab. Actually, okay. Till then, stay safe and stay healthy. Take care.
Okay, sir. Thank you, sir. Assalamu alaikum, sir.
Okay.
Assalamu alaikum, sir.
Okay.
Assalamu alaikum, sir.
Assalam.